right, let's get started. We have basically 2 more lectures after today. Okay, so today we will do the practice session for chapter 6. Okay. So chapter 6 is the last major chapter for this class. And then Thursday this week, we will do chapter 7, which is a pretty short chapter. And then the last class will be Tuesday next week. We will do a final review. Okay, do the final review. So by the way, for the final exam, it will be cumulative, which means it will cover chapter 1 to chapter 7. So practice session for chapter 6. Chapter 6 is all about hypothesis tests. Okay, here shows a list of equations I write down. Okay, you can see from here, I put down different situations, but all for hypothesis tests. So I put similar things side by side. For example, for test for population mean, okay, so we have a large sample and a small sample, okay, which coming from 2 different sections, section 6.1 and 6.4, okay, and also show the value we need to calculate, either the z value if the sample is large, or t value if the sample size is small, okay, and also here shows how p value can be found, okay, depending on how h0 is set up or h1 is set up. Okay, so here I said depending on how h0 is set up. Okay, so then you can figure out how to calculate the p-value depending on h1 is set up accordingly. Okay, so for example, if h0 is mu less or equal to mu 0, then h1 will be mu larger than mu 0. Okay, then the p-value will be to the right of z, and so on. Okay, so you can see that. Okay, then some other conditions. For example, if the sigma is not known, then we can use sample standard deviation when the sample size is large. Okay, and then here, for example, shows the degree of freedom for students t distribution. For t-value, we need a degree of freedom. Okay, so then test for population proportions. Okay, and then again the conditions and the statistics we need to calculate. Okay, and then for large sample, test for difference between 2 means. Okay, and then depending on how h0 is set up, okay, we calculate the z-score. Okay, when the sample size is small and we care about the difference between 2 means, okay, we need to calculate the t-value, okay, as usual. But for this situation, we have 2 different conditions. When the variance is not equal, which is the common case, or when the variance is equal, which is the special case. So we have 2 different equations. Okay, 2 equations for t-value. V here is still the degree of freedom. Okay, so different equation depending on the variance is equal or not. Okay, and this is 1, 2, 3, 4, 5. The next one is test for difference between 2 proportions. Okay, again, depending on how h0 is set up, okay, we calculate the z-score, and here are the conditions. I said at least 10 success and 10 failures. Okay, okay. All right, and finally is for pair delta. Okay, so for pair delta, the condition is it must normal. So must normal for small sample, just write down here. Okay, and then we calculate the t value when the sample size is small. For a large size sample, we calculate the z value. Okay, I found out this is very convenient to write down all the similar equations together, especially for chapter 5 and chapter 6. Okay, so I will do one for chapter 6 and another list for chapter 5, so I can write the equations side by side, also write down the conditions before I can use for each equation. Okay. Then, okay, so these are the questions we're gonna discuss. We're gonna work together. Okay. So I choose 5 questions. Okay. First one is on page 424, question number 6. Okay, which is here. Okay. So let's read the question together. So anterior cruciate ligament, or ACL, okay, runs diagonally in the middle of the knee. Okay, so one article by New Journal report result for 85 young athletes who suffered ACL injuries. Okay, so of the 85 injuries, 51 of them were to the left knee and 60 to the right knee. Then can you half of ACL injuries of the left knee? Okay, so can you conclude that? Tells us this is question from chapter 6, hypothesis test. Okay, and here is about proportion, right? Because 51 of 85 or 34 of 85. So this is a proportion question, right? So then we use the equation list. Test for proportion is from section 6.3. So that's the equation we will use for this question. Okay, we calculate the z value. Okay, so the sample proportion minus p0, and here is a function of p0 at the sample size n. Okay, so use that equation, and also the condition n times p0 larger than 10, and also this is larger than 10. Okay. So the first question is the test for proportion. Sorry. Okay, stop here. So test for proportion. Okay, so that's from section 6.3. First of all, let's write down the equation. We calculate the z value. Okay. Sample proportion, p0, 1 minus p0, sample size n. Okay. Then we write down the parameters from the question. Okay. So x is 51. Okay. So 51 is injury to the left knee. Okay, to the left knee. Sample size is 85. Okay. The sample proportion is 55 over 85. Okay. And then we set up H0 and H1. Okay. So again, how to set up H1 is whatever after can you conclude that will be H1. Okay. So can you conclude that more than half of ACL injury are to the left knee? So H1 will be P larger than 50%, 0.5. Okay. And then H0 will be P less or equal to 0.5. Then we calculate z-score here based on the equation. Right. So sample proportion is 0.6, P0 is 0.5, sample size is 85. Okay, so we calculate z-score. It is 1.84, very large. Okay, so then we calculate p-value. Okay, then for p-value, because H1 is in the form of p larger than 0.5. Okay, then the p-value will be the area to the right of z of 1.84. Okay, to the right of 1.84 here. Okay, so we use z table. I show the z table here. 1.84. So 1.8 is here. 1.84 is here. So 1.84 is 0.9671. Okay, 2.9671, that's on the left hand tail. Okay, so that should be 1 minus 0.9671. Which is equal to 0.0329. So that's the p-value. Okay, so p-value we compare to alpha of 5%. Okay, typically. So less than alpha of 5%. So we can reject H0 and conclude H1 is true. Okay, so we can conclude H1 is true. Okay, and you can repeat what is H1. We can conclude more than half of ACL injury are to the left knee. So that's the first question. So we have done this so many times. Okay, so as soon as we zoom in the right equation, remaining will be very straightforward. Right? So that's the first question. The second question on page 429, question number 6. Okay, it's here. So let's read the question together. A new process for producing a type of Novalec resin is supposed to have a mean cycle time of 3.5 hours per batch. Okay, 6 batch are produced, and the cycle time in hours showed here. Okay, so can you conclude that the mean cycle time is greater than 3.5 hours? Okay, so this is a test for mean value, and the sample size is small. Okay, so small test for sample mean. Okay, so which equation to use? It's here. Okay, section 6.4, small sample test for population mean, which we calculate the t-value. Okay, it's here. So t value, this is the equation for t value. Okay. And the degree of freedom is n minus 1. Okay. So first of all, we calculate whatever the question gave us, the sample mean. We just add this number together, 3.45, 3.447, and so on. Add it together, divided by 6. So the sample mean is this. And the standard deviation, we can calculate accordingly based on mean value and individual value. Okay, so I will just skip the details. This is the sample standard deviation. Sample size is 6. Okay, then the degree of freedom will be 6 minus 1, so that's 5. Okay, then set up H0 and H1. Okay. So can you conclude that the mean cycle time is greater than 3.5? So greater than 3.5 will be H1. So mu greater than 3.5 is H1. H0 will be mu less than or equal to 3.5. We calculate the t-score. The t-score here, the sample mean is 3.5067. Mu zero is 3.5, is here, from here. Okay. So sample standard deviation is here, and sample size is 6. Okay, so we calculate the t-value, the t is equal to 0.1943. Okay, so because H1 is asking mu larger than 3.5. Okay, so the p-value should be right of t. Okay, so t-value, the p-value should be right of t of 0.1943. Okay. Right. Then let's look at table 8.3, okay, which is the t distribution. Okay. So the degree of freedom is 5. So V is equal to 5. So t-value of 0.1943, which is less than here 0.267. 0.267 for alpha of 0.4. Okay, so that means the p-value will be larger than 0.4. Okay, for t value, we do not know the exact probability, but we can know the range. Okay, because t value of 0.1943 is on the left of 0.267. Okay, so that means the p value should be less than 0.4. So we do know, sorry, p value larger than 0.4. Okay, because H1 is in the form of mu larger than mu 0. So that should be on the right side. Okay, so which is very large. Okay, larger than alpha of 0.05. 0.05. So we cannot conclude the mean cycle is greater than 3.5 hours. So we cannot conclude H1 is true. Okay. So that's the second question. Then question number 3, page 436. Question number 10. question number 10. Okay, question number 10 is here. So in certain supermarkets, a sample of 60 customers who use the self-service checkout lane average 5.2 minutes to check out. Okay, standard deviation 3.1 minutes. Another sample of 72 customers use a cashier average 6.1 minutes and the standard deviation of 2.8 minutes. Okay, so that's the two average. The question is asking the difference between these two average. So A, can you conclude that the mean checkout time is less for people who use the self-service lane? Okay, so this is test for difference between two means. Then the sample size is 72 and 60, so larger than 30. So that's a large sample. Okay. So difference between two means. Okay. Which is here, the first case. Oh, no, first case here, 6.5, large sample test for difference between two means. Okay, so that's the equation. So we calculated the Z-score. So the Z-score equation is, let me copy this. Sample mean for X, sample mean for Y, delta 0. Sigma X for Sx, sample size, sigma Y, and sample size for Y. Okay, so we can use sample standard deviation to replace sigma. Okay. Then write down the parameters, the information given by the question. 5.2 minutes is for self-service, the average. Standard deviation, 3.1. Sample size, 60. Cashier, average 6.1 minutes. Standard deviation, 2.8. Sample size, 72. Okay. And then we set up each 0 and each 1. Okay. So again, each 1 is, can you conclude that the mean checkout time is less for people who use the self-service lane? Okay. So that's equal to mu X minus mu Y less than 0. Okay. 0 will be the delta 0 here. Okay. And then mu 0 will be, H0 will be mu X minus mu Y large or equal to 0. Okay. Then we plug in number into this equation. Sample mean 5.2 for X, for Y. Delta 0 is 0. Okay. And sigma X, we use Sx, so 3.1. Sigma Y is, we use Sy, 2.8. And sample size is 60 and 72. Okay, so plug in the number, we calculate the Z. It's minus 1.74. Okay. minus 1.74. Okay. So then we find the p-value because the alternative hypothesis H1 is asking mu x minus mu y less than 0. So less, we need to find the area to the left of z. Okay, to the left of z is here. Okay, so go back to table 8.2, find z value of minus 1.74. Minus 1.74 here. So 0.0409. Okay, so that is on the left hand tail, which is the question asking. Okay, so the p-value will be 0.0409. Okay, just less than alpha of 5%. Okay, so we can reject H0 and conclude H1 is true, and H1 is the mean checkout time is less for people who use self-service LAN. Okay. All right, and then let's look at part B of this question. Can you conclude that if everyone uses the self-service LAN, then the mean checkout time will decrease? Okay, because based on the test we just did, the self-checkout LAN, the average is lower. Okay, so we know that. So the mean checkout time is less for people who use self-service LAN. Okay, but can we conclude that if everyone uses the self-service LAN, then the mean checkout time will decrease? Okay, so actually we should think about all the possible reasons people using either cashier or self-checkout LAN. So the answer is we cannot conclude that the mean checkout time will decrease if everyone uses the self-service checkout. Okay, so one of the possible reasons is those customers who currently using the cashier, they may have a lot of more items than those who are using self-service LAN. Okay, because they have more items to check out, so they choose to use cashier. So that's very possible. If that's the case, then the question in part B will not true. We cannot conclude that if everyone uses the self-service LAN, the time will decrease. Okay. So that is question number 10. Our third question. Right. The next on page 442, question number 12. Here. So in a study conducted by US Department of Health and Human Services, a sample of 446 boys aged 6 to 11 was weighted. It was determined that 87 of them were overweight. Okay. Another sample of 508 girls at age 6 to 11 were also weighted, and found 74 of them are overweighted. So can you conclude that the proportion of the boys who are overweight differ from proportion of girls who are overweight? Okay, so this question is asking the difference between two proportions. Okay, so very clear. So difference between two proportions. will be the question here. Okay, so section 6.6, difference between two proportion. Okay. So the condition is we have at least 10 success and 10 failure, and we calculated z-score here. Okay. So that's the equation we're going to use. So z-score. So sample proportion for x, sample proportion for y. Okay. And this is pooled proportion. Or minus pooled proportion. Then nx, sample size for x, and the sample size for y. Okay. And here are the equation for sample proportion for x, for y, and for this is the so-called pooled proportion. Okay. Right. Then write down x, so 87 boys over weight. The sample size for boy nx. Okay. The sample proportion for px, 87 over 546. Okay. For girls, 74, sample size 508. Sample proportion for girl. Okay, and the pooled proportion. Okay, so x plus y, 87 plus 74, divided by sample size for x and y, add it together. So that is pooled proportion. Okay, and then set up H0 and H1. Okay, so H1 will be, can you conclude that the proportion of boys who are overweight differ from proportion of girls who are overweight? So differ means they are not equal. Okay, so in other words, px minus py will not equal to 0. So that means they are different. Okay, then H0 will be px minus py equal to 0. Okay, and then we plug the numbers into the equation for z. Okay, so I will just skip the details. It's very straightforward. So calculate z-score. Z is 0.62. Okay, so not very high z. Okay, then we calculate the p-value because the alternative hypothesis H1 is in the form of not equal. Okay, not equal. So the p-value will be the sum of two tails on the right and the left. Okay, so p-value sum of two tails. Okay, so for the z value of 0.62 and minor 0.62. Okay, so sum of two tails is here. Okay, all right. So again, use table 8.2, the z table. For z value of 0.62, 0.662 is here. Right? So 0.7324. So that's the left-hand tail. So for the right-hand tail, on the right of z value of 0.64 will be 1 minus 0.7324. 7324. 1 minus 0.7324. That is 0.2676. Okay, so that's here, this area. All right. Then the other tail, the left-hand tail is also same because the z table is symmetrical. Okay, so the p-value will be 2 times 0.2676. Okay, very large. So we cannot. So when p-value is larger than alpha, 5% normally, then we cannot conclude H1 is true. Okay, and H1 is, we cannot conclude the proportion of boys who are overweight differ from proportion of girls who are overweight. Okay. So after this practice, you have a pretty good idea, I think, about the procedure to do this. And it is very easy to zoom in which one of these 8.7 equations to use, as I show here. Okay. So that's question number 12. We have one more question left for today, which is page 456, question number 9. Question number 9 is here. Okay. So question number 9 gives us a sample, a table, sorry. Okay, so that tells us it is a pair data. Okay, all right, so let's read the question together. So a crossover trial is a type of experiment used to compare two drugs. Okay, so subjects taking one drug for a period of time, then switch to another drug. Responses of the subject are then compared using matched pair method. In one experiment, compare two pain reliever. We have 7 subjects took one pain reliever for 2 weeks and then switched to another. Then they rated their pain level from 1 to 10, with larger number representing higher level of pain, as we can show from the table here. Okay, so we have 7 subjects taking drug A and drug B. Okay, so can you conclude that the mean response differ between the two drugs? Okay, so for pair data, the equation will be here. Okay, then depending on the sample size, large or small. For large, we use Z. For small, we use T as usual. Okay, so we have 7 subjects. So obviously, this is the small sample. So that's the equation. We use t value. Okay, so let's pair delta. Small sample, we use t value, t score, the mean value for the difference, mu 0, standard deviation for the difference, sample size n. V, degree of freedom is n minus 1. Okay, so based on that table, we first of all calculate the difference. The difference, the first one, drug A, 6, drug B, 5. So 6 minus 5 is 1. Okay. For subject number 2, drug A is 3, drug B 1. So 3 minus 1 is 2. Okay. So you can calculate the remaining. For 3, 4 minus 5 is minus 1. Okay, minus 1. Okay. So from there, we can calculate the mean value for the difference. So this is the mean value for the difference. We add all the numbers together, divided by 7. So that's 0.714. Okay. And then we can also easily calculate the standard deviation for the difference, okay, depending on the individual values and also the sample size and also the mean value. Okay. So that's turned out to be this much. Sample size is 7. Degree of freedom is 7 minus 1 is 6. Then let's set up H0 and H1. H1 will be, can you conclude that the mean response differ between the two drugs? Okay, so differ means the mean value for the difference will not equal to 0. Because if it's equal to 0, then there will be no difference. Okay. Then H1, H0 will be the opposite. The mean value for the difference is equal to 0. Okay. And then we calculate the t-value based on the number we just calculated. The mean value for D, mu 0 is 0. Okay, so that's here. Sample standard deviation is this. Sample size n is 7. Okay, so plug in the number, we calculate dt. Okay, then we calculate p-value because H1, the alternative hypothesis, is in the form of not equal. Okay, then not equal means the p-value will be the sum of two tails of t and minus t. Okay, so two tails of t and minus t. So go to table 8.3. Here. So the degree of freedom is 6. So that's here. Okay. So the t-value is 1.3693. Okay. So 1.3613 is between these two values, 0.718 and 1440. Okay. So which means it will be between alpha of 0.1 and 0.25. Okay. And because that's two tails, so 0.1 times 2 will be 0.2, 0.25 times 2 will be 0.5. So that is between 0.2 and 0.5. Okay. The p-value will be between 0.2 and 0.5. So anyway, it is larger than alpha of 0.05. So we can not conclude H1 is true. Okay. As you can see, the procedure is almost the same, always the same. Okay. So the tricky part is one, decide which equation to use. Okay. And two, depending on how H1 is set it up. H1 larger than 0, then the p-value will be the right of t or z. Okay. If H1 is less than 0, then the p-value will be left of t or z. Okay. If it's not equal to 0, then will be the sum of two tails. Okay. Right. So I believe that's the last question for the practice section of chapter 6. Okay. So we're done for today.